This is my homework for lesson number 39 for the Arduino UNO R4 Wi-Fi uh, series that Paul McWhorter has on YouTube. He asked us to take a program that's written in a normal way and then set it up so it'll run on functions instead of in the main loop. So if you look here, this guy is the homework we had for him, like 32 or something like that. Anyhow, it's got to do with the oh darn it, what I think here, the DHT11 and using the DHT11 with a matrix display. And I set up another display so you could have a continuous display after the what do you call it? Windows finishes scrolling on the matrix. Anyhow, up here I included DHT.h. I've defined the DHT pin and told it what type of DHT it is. And I've included Arduino graphics and the Arduino LED matrix. That's for the LED, or the little matrix that's on the board. And then we have include this, where's it at? Oh, there it is. Okay, anyway, we include all this stuff, include the Adafruit ILI 9341 for this little display. And here's the different pins. The CS connect pin 8, resets pin 9, and DC is pin 10. Anyhow, here I define the TFT object using the ILI 9341 library. And then we have the DHT, which is also defining the DHT object. Down here we do the Arduino and we define the Arduino LED as the matrix. That's all the objects we have to define. Here we set up variables. Temp C, temp F, humidity, HIF, HIC, butt pin 3, baud rate 15,200, and the setup delay of 100 or 1,000, and the measured delay is 1,000, which is basically a second. And the new butt state and the old butt state are defined here. I set them for 0 so that first time through it all runs. Then the rotation equals 3, which allows the display to be rotated this way here, otherwise it'd be going up and down. And then we have string 2 messages. Message goes to the matrix and message 1 goes to the display. Then we have setup. We set up TFT begin, that starts a display, and my ADHT begin starts the DHT, and the matrix begin, we start the matrix. And then we call out the butt pin and added a pull up. This defines it. Then the TFT cursor I set for 0, and I set the fill screen to 9341 black, so that once it comes up, it'll if I reset the thing, you can see the display is dark right now. The light is light, then it clears it down to black, so it's not lit up. Then we have void loop. Here's the main stuff. I got one function called read sensor, one function called print data, and that is it. Now if you come down here to read sensor, here's all the stuff for the sensor. Temp C equals DHT read temperature, and that's false. Temp F, DHT read temperature, and that's true. Okay, now then there's humidity, HIC, HIF, which I'm not using in this particular program because it's easier not to have all that on that matrix display. It takes too much to scroll across all of that information. And anyhow, we have the set the rotation. That was the 3. Set the cursor to 0, 0, black and white. Text size. And if this thing, or either one of, or any one of these things fail, it'll pop up and say read data, fail to read data on DHT11. So let me show you. If I disconnect the DHT11, you'll see there it goes. It doesn't stay there very long, but it says failed to read data on DHT11. So if I hook that back, that'll stop, but it didn't clear it, and I'll have to reset it again. Anyhow, you can see where that actually works. And that's where the reading the data. And then here's where I print all the data. We set up messages. This is for the message. The first message here is for the matrix. Message 1 is for the display. And you can see the only difference here is I put in a character 247 for the degree symbol. Down here, I set up the button for new butt state, digital read butt state, and then we do the identify whether the button's been pushed or not. Then we go down here. I begin to draw. Then we're working on the matrix, this first half, and it'll display this, and it'll scroll left. Down here, I set up the rotation, clear it to black, and then make the text white. Also text size 3, and then I set the message 1. So then I got the old button equals new button, so we keep track of what's going on with the button. Okay, now let's go up here. I like to have it up here when I'm running. Okay, now if I push the button, you'll see that this matrix starts to scroll, and I get degrees F. Humidity is 20%, and that'll display on the display here. You can this camera isn't the greatest thing in the world, but you can barely make out that there's a degree signal there, and the 20% here as well. And you'll look here, you can see that I have a level converter. Here's the signals coming out. These are the high voltage signals. They go to this level converter, high voltage input. Then they have a low voltage output, which is 3.3 volts. That goes to display, because this display, even though the stupid data sheet says it's good for 5 volts, it does not work. And you will blow it up if you put 5 volts into these things. So anyway, I converted it down to 3.3 volts logic and use it. Anyhow, there's my homework, and I appreciate you doing all these, Paul. And bye, guys. I'll see you on Tuesday.